Assalamu alaikum. Welcome to your second lecture in Principles of Computer Networks. We will continue the introduction. In this lecture, we will cover network softwares and reference models. In network softwares, we will discuss protocol hierarchies, connection-oriented and connectionless services, service primitives, and relationships between services and protocols. A protocol is an agreement between two communicating parties on how the communication will be carried on. In the context of computer network, the protocol is a formal set of rules that governs how two computers exchange information in a network medium. A set of layers and protocols is called a network architecture, and a list of protocols used by the certain system, a layer per protocol per layer, is called a protocol stack. Protocol stacks, network architectures, and protocols themselves will be the subject of this course. Example for a hierarchy, a network structure, here is a 5-layered model. This layered model consists of 5 layers, each of which has a layer protocol to communicate with its peer layer, and each lower layer provides certain service to the upper protocol. The protocols, the adjacent layers, communicate through an interface with each other, and the peer protocols communicate through a protocol. Here, the actual communication is presented by a solid line, and the virtual communication is presented by a dotted line. That's to say, the actual communication happens between the adjacent layers, where the virtual communication happens between the peer layers. In order to make a model, there are certain things to be considered: the number of layers, the name of each layer, the function of each layer, the content of each layer. An example for this, we have two philosophers that would like to communicate. One of them speaks English and Urdu, and the other speaks French and Chinese. Apparently, they cannot communicate directly, so they need translators. The translators speak English and Dutch, and the other one speaks French and Dutch. So they will use a common language, which is Dutch, to communicate with each other. There are secretaries who are in charge of the actual communication, of sending the data physically. So if the first philosopher who speaks English and Urdu will says in English, "I love rabbits," the translator will translate it into Dutch and send it to the secretary. The secretary will send it through a fax machine, for example, to the other secretary on the other side. The secretary on the other side will transfer data to the upper layer, that's the translator, in Dutch, and the translator will translate it in English, in French, to the philosopher in the upper layer. So the medium layer provides service for the upper layer, that is translation, and the lower layer, layer 1, provides services to layer 2, that is data transmission. The middle layer can change the common language, for example, to Arabic, and this won't affect the upper layer. And the lower layer can change the means of communication to email or regular mail or phone calls or even in person, and this won't affect the upper layers. If you want a more technical view of this, we will go through the same model we have been using. That is the 5 layers model. The message is created by the 5th layer. This message is meant to be sent to the 5th layer on the destination machine, but the message actually is sent to the 4th layer, where the 4th layer adds control information such as the address of the destination machine, how many bytes are there in the message, and so forth. The message and the header are passed to layer 3, where layer 3 also will add header, but layer 3 will split the message into 2 messages because For example, the data units in layer 2 are smaller than the message. Then it will add its headers to both parts of the message and sequence the message as message 1 and message 2. Layer 2 will add its header and trailer maybe to the messages and send them to the destination through the physical layer. That is layer 1. When the messages are received at the destination, each layer will read the header of the corresponding layer, of the peer layer, and strip this header and then pass the message to the upper layer. When the message will reach the layer 5, it will be just a message without any headers, and the message will be actually reassembled in layer 3 because layer 3 has done the deassembling. And this is how it will work. We will see more of this when we discuss the reference models. The network software layer design issues are addressing how to name or address the communicating parties, how the sender will identify the receiver, the channel control. If the communication channel simplex, that's to say the data goes in one direction at a time, or duplex, the data goes in both directions at a time. If the data channel and there is data channel and control channel like ISDN, or only data channel like Ethernet, for example. How error is detected and corrected. How control flow is done, so the sender will not overwhelm the receiver with data. How messages are assembled and deassembled and reassembled. How multiple streams of data are multiplexed into a single channel and how they will demultiplex at the destination. How the message itself will be routed from source to destination through intermediate networks. That being said, we will discuss services. A service is what a layer provides for the layer above. It tells the layer above what the layer will do. In our example, layer 2, the translators will tell layer 1 that they will translate from the language from English, for example. But it doesn't tell them what the entities within the layer does or how the layer works. There are two types of services: connection-oriented service and connection-less service. Connection-less service does not need to establish connection before starting sending packets and does not require authentication to packets sent and does not require sequencing to packets that be received at the same order they were sent. It's also route each packet individually, so packets does not have to follow the same route. While connection-oriented services must establish the connection before sending the packets, and authentication is required before starting sending the packets. Every packet has to be received in the same order it was sent, and the packet's delivery has to be acknowledged from the receiver to the sender, and all packets follow the same route. Connection-less services require less bandwidth. It's possible to happen for congestions to happen, and it's less reliable. While connection-oriented services requires more bandwidth, congestion is not an issue, and it's more reliable. Connection-less services are much cheaper in terms of time, bandwidth, and money, and connection-oriented services are much expensive in terms of time, money, and overhead, but it's more reliable. An example for connection-oriented service would be a sequence of pages sent over the network, a file, for example, or remote logging from client to server, or a digitized voice, for example. Connectionless services like electronic junk mail that can be sent without the need to acknowledge the receiving. It can also have acknowledged datagram in things like registers mail or in instant messaging where you require delivery report. Request reply like database query. You can come up with other examples, of course. To actually understand a service better, we will have an example of how service work. Here we have a service is formally specified by its primitives, that's to say its basic operations. In our example, we have a connection-oriented service with 5 primitives. Listen, that is a blocking system call for the server to wait for a request from the client. Connect is a request from the client to the server to establish connection. Receive is a blocking system call from the server to wait to receive the messages from the client. Send is a system call from the client to send data to the server. And disconnect is a system call to tear down the connection. In further details, a client machine has a client process. This client process issues send connect system call. This is sent to the kernel, from the kernel to the protocol stack, then to the device drivers, then to the actual devices, network devices. The connect request goes to the server, who is blocked listening to the requests. When the server gets the request for the connection, it will send an acknowledgement to the receiver, so the connection will be established. Next step, the receiver will send the data request to the server, where the server will reply with the relative data. When this is done and the client does not need anything more from the server, it will tear down the connection, sending a disconnect request to the server, where the server will reply with a disconnect acknowledgement and the connection will be down. Interfaces are the means with which each layer communicates with the above layer. It tells the layer how to access the above layer, what set of parameters are there, and what the result to be expected. Here we can see how two adjacent layers, data link layer and network layer, communicates through an interface where the data link layer, the lower layer, is the service provider, and the upper layer, the network layer, the service user. And they communicate through service access point. That is the interface between the two layers that determine the parameters to be passed and the results to be expected. A service is actually a set of parameters that a layer provides to the layers above, and a protocol is a set of rules governing the communication between peer layers. Communication through a service is an actual communication. Communication through a protocol is a virtual communication. Communication through a service is carried vertically. Communication through protocols is carried horizontally. See you in the next part.